So what do I mean by systems of nonlinear equations? Talk to me about vocabulary. What's a system of equations?
Equations.
More than one, right? More than one. So a system are, if we had two lines, what would those two lines be doing? Crossing, right? That's one possibility, is that they would cross. What's another possibility?
They would stay like that.
Parallel, right? And what's the last possibility?
90 degrees.
Right on top of each other, right? So linear equations, those are the possibilities, right? What about nonlinear equations? What could be in a nonlinear system?
Bend.
What kind of bend?
Circular bend.
A circular bend.
Triangles.
We could have parabolas.
Yeah, that.
We could have exponential functions. We could have... Could you have a line in a nonlinear system? Yes, right? It's just that everything isn't a line in a nonlinear system, right? At least something is not a line to be a nonlinear system, okay? So what if we had a parabola and a line? How many solutions could I have? Two? Two, one, and none, right? Because if my parabola is there, I could have two, like right here. 1, 2. I could have one. How? If it was like that, where it crosses one time, what's that called, by the way? Think back to geometry for me real quick. What's that called? A tangent, right? A tangent line, okay? And then I could have a line over here where it doesn't cross the parabola at all, right? Those are the three options if you have a quadratic and a line, right? Is there any chance that you could have a line and a quadratic and have three solutions? Like, is this quadratic, is this parabola going to come back down?
Probably not.
No, never, right? It doesn't do that, okay? So that's the options. What if we have two parabolas? What are the options? Okay, here's one parabola. How many solutions could I get for this?
2, 3.
So how could I get two solutions?
One circle on the left and a circle on the right.
So like, what if the parabola was like this? How many solutions is that?
2.
Two, because why?
They cross right there and
Right there and right there, right? So how many other types of solutions could I have? If I have a parabola here, what else could I have? Could I get one solution? How? Yeah, you got to remember all the properties of parabolas, right? We know they don't come back down. We know they keep expanding all the way up and all the way out, right? What about this? Is this going to be one solution?
Yep.
Where is the solution?
Right here.
Right there, right? This is going to keep going that way. This is going to keep going that way. They're not going to touch again. Okay? Is there another way I could get one solution?
Yes, they can. One can be going this, and one can be going like this, and they can barely touch.
So you're like, you're saying right there and right there?
Yep.
So like that?
But you could also get none when they don't touch at all.
Oh, absolutely, right? If one is here, like this, and one is, I don't know, over here, there's no solutions, right?
Right.
What if I had, okay, so we're not going to go all the way down this path, because this path would take us down to like infinity of possibilities. Okay? We don't have time for that. I have a concert to be at tonight. Okay?
What concert?
Abilene Community Band, I'm playing it.
Oh, nice.
Yeah. Okay? But what if I had a parabola and a square root function? Well, first of all, you have to remember what a square root function looks like, right? Maybe it's a parent function that has a vertical stretch, and maybe it goes like this. How many solutions are right there?
2.
2. one there, one there. Could you easily see how this could only have one solution?
Mm-hmm.
If it started here and went like that, right? Touches right there. Could you see how it could have no solutions? Maybe it even shifted down and went that way. See, it's not touching at all, right? Because we also have rational functions, we have exponential functions, we have all the functions we've studied this year so far, right? All I've done so far is said, what if I started with a quadratic and added some other kind of function? Could I start with a square root and add a rational? Could I start with a square root and add an exponential? Could I start with an exponential and add a quadratic? Yeah, all of those are possible. So you see why I'm not going down all of the paths? Yes? Okay. But do you get an idea of how many answers we could possibly get for different things? Okay. So then what if I tell you that this is my system? Y equals x squared plus 4x plus 5 and then y equals x squared minus 2x minus 6. And I ask you to solve it by graphing it. Because isn't that one of the ways we know how to solve a system, is by graphing? So how are we going to do that? Oh, calculator, okay. So I'm going to turn it on, and I'm going to add a new page that is a calculator, a graph page. So first of all, I need x squared plus 4x plus 5. And then I need to hit tab again to get my entry line to come back up. And I need x squared minus 2x minus 6. So the first thing I have to do is draw my graph. How many times did we expertly, very, very carefully, cautiously draw graphs in here?
No, I've done it a couple times.
We've done it quite a few times.
Oh.
We were supposed to have done it quite a few times. A lot of us did. Some of us did not.
We'll do it. Probably
It's
not.
okay. Okay? My point I'm trying to make is I'm not caring if these are exact. I need them close. Okay? So let's see. How about... Is that pretty good for the first one? For the bigger one? When I say bigger one, it's just lower. It's not really bigger, is it? And then... like that? Is that pretty good?
Sure.
Now, was I super careful? No, but was I super careful? Yes. I need it close. Okay? What's the important place that I need to find right here?
The where it touches each other.
So right here. Right? That's my solution, isn't it? Where they cross is my solution. In this particular case, how many times do they cross?
Once.
Once. Right there. Okay? So is it about -2, about 1?
Yeah.
Ish? Or can we be exact?
You can be exact.
Oh, then let's be exact.
Menu
Let's be
something.
exact on the solution, right? So menu,
5. No, 7.
analyze.
6.
What are we looking for?
4. Intersection.
Intersection. Now, it's asking me lower bound. That means it moves. I need to move this dotted line to the left-hand side of the intersection.
Click.
And I need to click. And then I need to move it to the right-hand side because it says upper bound. Ooh, did you see that happen? Let me go back. I'm right here. We know our point of intersection is right there, right? Watch what happens when I pass that.
It tells you what it is.
Oh, it shows up, right? Now I still want to click. That's hard to read because it's right on the line, so I'm going to control grab it. See how the hand closed? And then I can move it over so I can see it better. So what is my solution?
Negative 1.83, comma 1.03.
Any questions? What if this red one went like this and there was a solution here and a solution here? Could I just put my lower bound here and my upper bound here and see both of them at the same time?
No.
Calculator won't let you do that. You just have to do that twice. What do you press again?
Menu 6.
Menu, analyze, intersection, right? And then you press your lower bound and your upper bound. Does that make sense?
Mm-hmm.
Any questions on how to find the solution if I ask you to solve it by graphing? Everybody okay with that? Okay. However, what if I give you this? Y equals x squared plus 5x minus 8. Y equals negative x squared plus 2x plus 12. What if I say, here's your system, solve it algebraically? Well, we don't want to do, we don't really probably want to do elimination. We probably want to do substitution. Do you remember how to do substitution? Well, aren't these both set up y equal, y equal? If y equals this and y equals this, doesn't this equal this? Set them equal to each other? So x squared plus 5x minus 8 equals negative x squared plus 2x plus 12. So how do I go about solving this?
Plus 8.
Do we want to get everything on the left-hand side or everything on the right-hand side?
Right.
Doesn't matter.
No.
It doesn't. So personally, I would get it to the left-hand side, because if I move it all to the right-hand side, what's going to be true about my a value? It's going to be negative, right? So I'm going to go ahead and add x squared to both sides. Are you okay with that? Okay. And subtract 2x from both sides. And subtract 12 from both sides. So what does that give me?
2x squared.
2x squared.
Plus 3x.
3x
And minus 4.
equals 0. How do we solve a quadratic like this? We could try to factor it for sure, right? So AC, negative 40, right? A times C, do you remember this? A is here, B is here, C is here. So first we find AC. AC is 40, because 2 times negative 20 is negative 40. And then what's B? 3. So what two numbers multiply to be AC and add to be B? Well, let's see. 1 and 40 multiply to be 40. 2 and 20. And 3 doesn't work. 4 and 10. 5 and 8.
Oh, that one.
Oh, that one? What kind of 5 and what kind of 8? A negative 5 and a positive 8. Do you see how that works? So then I need to rewrite my problem and split my middle term into those two parts that I just found. So 2x squared minus 5x plus 8x minus 20 equals 0. And now we are factoring by grouping, because there's 4 terms. Do you remember this? Starting to come back to you. Okay. What's common in the first 2 terms? An x. If I take an x out, what's left? 2x minus 5. Very good. What's common in the last 2 terms? What are they both divisible by? 4. Keeping in mind that your parentheses has to be 2x minus 5, so if you can't think of it off the top of your head, what do I have to divide this by to make it become 2x? Right? A 4, right? So take out a 4, and if I divide both of these terms by 4, what am I left with? So it worked, right? It did what I needed it to do. Yes? So now what's common in these 2 terms? 1, 2. What's common in those 2 terms? A 2x minus 5. And what's left over? X plus 4. What does this tell me? If these multiply together and it equals 0, what do I have to do with each one of those? Very good. So 2x minus 5 equals 0, and x plus 4 equals 0. Add 5 to both sides. 2x equals 5. Divide both sides by 2. X equals 5 over 2. Subtract 4 from both sides. X equals -4. Is that my answer? No?
We'll plug them in, right?
Okay, think about this for just a second. I have two parabolas, right? I know they're parabolas. They're both quadratics. I have two parabolas and I solve them and I have two x values. What does that mean? How many solutions do I have? Are these the two solutions? Knowing what your solutions have to look like. Are these the two solutions, or are these the two x values of the solutions?
Yes, X value.
X values. Okay? So what do I need to do with both of these?
Plug them in.
One at a time, right? I need to plug them in one at a time. So if I choose 5/2, I think probably, if I was to guess correctly, I think most of you would want this to be 2.5 if we're plugging stuff in. Is that correct? So when x is 2.5, I'm trying to find the y value, right? So I need y equals 2.5 squared plus 5 times 2.5 minus 8, right? So I need my calculator to come on, okay? And I need a calculator page this time, don't I? 2.5 squared plus 5 times 2.5 minus 8. 10.75. So when x is 2.5, y is 10.75. What happens when x is -4? Don't I do the same thing? Y equals -4 squared plus 5 times -4 minus 8. So -4 squared plus 5 times -4 minus 8. Do you see my error? Does anybody see my error? This should be what? Times or plus? Right? Plus? So -12. So when x is -4, y is -12. These right here are my two solutions. So what does that mean? How many times do these two parabolas cross? 2 times. Okay? Any questions on how to solve by graphing? Any questions on how to solve with substitution? Now, is anything that I just did, is any of that new? None of it is new, is it? This is all stuff we've done before, but we've never done it before like this. We've never done two parabolas before, right? It's always been two lines, or a line and a parabola, or something like that. So that's why this is a whole new unit, because we're taking all the stuff we've learned this year and putting it all together. Does that make sense? Any questions?